Hey guys, how are you all? I hope you all are doing well. Myself Swapnil sir and welcome to very first lecture recap lecture series on line and plane chapter. Already we have started recap series like a vector chapter, another determinant matrix chapter 2. So but in my today's video I'm going to explain to you all one of the very much important concept from our mathematics, which is a line and plane chapter. Okay, so which is very much important in the perspective of our upcoming board exam. Okay. So first of all, in my today's lecture, I'm gonna explain to you all some of the basic concept from the line and plane chapter. Then at the end, we will move for some of the examples from the board exam. Okay. So already I have uploaded one short video on line and plane chapter. So if you are interested to see this video, do check in my playlist. You will get the entire video there. Now, in my today's video, first of all, we go for understanding the concept from line and plane chapter. Okay. So without further ado, let's dive into our today's lecture. We will see first of all the some of the concept from our line and plane. Then at the end, we will move for our some of the example based on line and plane. Okay. So now at the beginning here, we need to know some of the concept from the vector, okay? Because vector and line and plane chapter both are interrelated chapters, okay? So if your concepts are good from the vector chapter, I don't think so is anything difficult here in a line and plane chapter, okay? The condition for collinearity, coplanarity, if the vectors are perpendicular, parallel, all these conditions are here applicable in our line and plane chapter. So okay, so already I have uploaded one short video recap video from our vector chapter. So if you are interested to see this video, do check in my playlist. Okay, so once you come to understand all these recap videos, so today's video I don't think so anything difficult here. Okay, now without further ado, let's dive into our today's lecture. First of all, we see the what is the collinear vector, coplanar vector. When vectors are perpendicular, then how can we define? When vectors are parallel, then how can we define? Okay, yes, we will see everything here. Some of the section formula like condition also applicable here in our lecture. Okay, so we will see first of all what the basic condition here we have here. Okay, so as earlier we have learned already the collinear vector, coplanar vector. Okay, so we'll just go for the little recap about them. Okay, yes, collinear vector. Collinear vector. Okay, so why I'm taking these points from the vector, because these are needed here to get our next solution done. Okay, and further topic also important here. We'll see the topic while we are solving the examples. Okay, not right now. No, right now we go for some of the basic concept first. Okay, so collinear vector first. After that, coplanar vector second. Okay, collinear vector. What is mean by collinear vector? The vector or the line segment or the vector which lies in a along line or a parallel line, okay, under same plane. Now we can see that a collinear vector I can define here shortly. Now these two are this one and this one. Consider this line segment AB and the line segment BC. Both are the parallel line segments. Okay, both are the parallel line segment. Then we consider this one is the collinear vector or collinear line segment. Okay, this is condition for parallel. So if we go from like along lines like a line segment AB which along with a line segment BC, then we consider this one is the collinear vector. Okay, so this one is the definition for collinear vector. After that, coplanar vector. Coplanar means in our simple language, coplanar means the vector which lies in our same plane. Okay, which comes under single plane, we consider it as the coplanar vector. Okay, there are some other conditions that are helpful here for finding the whether vectors are coplanar or not. Okay, now after that, if we have two vectors are perpendicular, now consider that if I consider A bar and B bar, okay, A bar and B bar, both the position vector. Okay, I consider here both are the position vector. Okay, and these two position vector are perpendicular to each other. Okay, so if both of the position vector are perpendicular to each other, then how can we define their dot product and cross product? Okay, now first here the dot product gives us A dot B which is equal to 0. So A dot B which is equal to 0 gives us the A bar and B bar both are the perpendicular position vector. Okay, so we write their dot product as 0 when we have two vectors perpendicular to each other. Okay, similar like when we have condition two vectors are parallel to each other, then how we define the their vectors. Okay, in mathematical form there are some certain condition that we have to hold it here. Already I explained all of these condition in my previous lecture, so if you are interested to see, go from these videos. Okay, now after coplanar and collinear vector, we have a cross product for three vectors. Okay, or dot product or cross product of three vector. How can we define? Like if we have vector a bar, vector b bar, vector c bar, these three vectors here. Okay, these three vectors, and if you wanted to find out the dot or cross product, then we can write it as the a bar dot b bar cross c bar. Okay, a bar dot b bar cross c bar. Okay, and the cross product for the two vectors, we take their coefficient. Okay, or we directly go for the coefficient for a1 b1 c1 from our coefficient of our position vector, like a2 b2 c2 a3 b3 and c3. This one is our determinant. Okay, so we have to find out the value for this determinant. That means this is the value for vector a bar, b bar and c bar. Okay, these all things we have learned here. Now we are going to apply this condition in our subsequent example. Okay, now let's get start our today's lecture with some of the example which based on line and plane. Okay, so these examples from line and plane. Okay, now let me read the question. The acute angle between the line. Okay, so in our question we have given the acute angle between the line. Okay, and line given x plus 1 divided by 2, which is equal to y divided by 3, which is equal to z minus 3 divided by 6. Okay, so what we have line here, our line says that the acute angle between the line. Okay, the acute angle between the line. Okay, between the line. Okay, this one is our claim here. Okay, so we have to find out the acute angle between the line. Okay, this one is the claim in our example. What is the acute angle between the line and the line and a plane it is given. Okay, so when we have equation for line and another equation for plane it is given. Okay, so equation of a line, it says that equation of a line, it says that x plus 1 divided by 2, which is equal to y divided by 3, which is equal to z minus 3 divided by 6. Okay, this one is, we have equation of a line here. Okay, so equation of a line we have given x plus 1 divided by 2, y divided by 3 and z minus 3 divided by 6. This one is our equation of a line given. Okay, and after that we have given equation of a plane. Okay, equation of plane. Okay, so this one another given in our example, equation of a plane, 10x plus 2 times y minus 11 times z plus 11 times z, which is equal to 8 here. Okay, so we have given equation of a plane over here. Okay, so which is 11 times z. Okay, yes, this one is the equation of a plane we do have here. Again, equation of a line also given. Okay, and using this we have to find out the acute angle between the line. Okay, and when we have equation between line and plane we have given, and we want the acute angle between the line, so in this case we use the result for sine theta. Okay, we use the result sine theta for finding the acute angle between the line and plane. Okay, so how can we write acute angle between the line and plane? We define it as the sine theta, which is equal to b bar into n bar upon modulus of a b bar into modulus of n bar, all comes under this modulus. Okay, yes, this one is the acute angle between line and plane. Okay, so we convert it as we use it as the b bar dot n bar into modulus of b bar into modulus of n bar here. Okay, yes, now we have to define here b bar and n bar first. Okay, using our given data we have to define b bar and n bar, then we proceed with the value of sine theta. Okay, further part it is quite easier for the calculations. We just need to know the value for b bar and n bar. Okay, so let's go to find out the value for b bar and n bar. Okay, so value for b bar. Now see that the vector which is coming from this equation of a line like a 2, 3 and a 6, which gives us the value for b bar, okay, which is the vector b bar, okay. So what is the vector b bar we have here, which comes from this equation of a line, okay. So which is the 2 times I plus 3 times j plus 6 times k. I introduce ijk here, okay. So we write 2 times I cap plus 3 times j cap plus 6 times k cap, okay. So the value for b bar here, 2i plus 3j plus 6k, using the equation of a line, I found it here, okay. And using n bar, okay, we want the equation of plane here, okay. So using n bar, we can define the equation of a plane over here, okay. So n bar can be written as, okay, using n bar, we can write equation of a plane. So the coefficient of x, coefficient of y and coefficient of a z, which is the value for n bar, okay. That means we write 10 times I cap plus 2 times j cap minus 11 times k cap, okay. This one is the value for n bar here, and this one is the value for b bar, okay. Now here it is only the challenging part, that how can we define the value for b bar and n bar, okay. Yes, that you need to understand. So the b bar, it says that the vector which coming from the direction ratios which coming from the equation of a line, okay, and the n bar, it says that the value which coming from the equation of a plane, okay. So we have to introduce ij cap here, both of here, okay, and then we got the b bar and n bar, okay. So it is easier to find out the b bar dot n bar, okay. Now one more thing, how can we find out the modulus for any number, okay. So we take their under square root the coefficient of ijk square under square root, we take it, this one, okay. Now for example, let me explain the modulus of a b bar. How can we define modulus of b bar, okay. So I want the modulus of a b bar using b bar, okay. So modulus, it says that what we do, we take under square root the coefficient of a term square, okay. So under square root, okay, we take under square root first term coefficient square, that means 2 square, plus next term's coefficient square plus third term's coefficient square, okay. So we can see what I have done basically here, I taken the first term's coefficient square, which is a 2 square, second term, third 3 we have here, take the square of a 3, and the third term we have similarly 6 square, okay. Similarly we have to go for the n cap, okay. So modulus of a b bar can be written as 2 square 4, 3 square 9 and 6 square 36, okay. So we will get it is the completely 49 under bracket, okay. So 36 plus 4 40 plus 9 49, okay. So which gives us modulus of a b bar, which is equal to 9, okay. This one is the value for modulus of a b bar we have here, okay. Similarly find out the modulus of n bar, okay. Modulus of n bar here, okay. So modulus of n bar, what it is says that, so take the coefficient of I, coefficient of j and coefficient of k, their addition and their square under square root, okay. So we can take it under square root 10 square, okay, plus 2 times square 2 square, okay. That means 2 times j is there now, that's why we have to take 2 square, then minus of plus minus of 11 square, okay. We have to be very much careful because that negative sign goes under square root square, okay. So we go for the next 11 square, which 121 plus 10 square 100 plus 4 square 2 square 4, okay. 125 plus 100, which goes to 225, okay. This one goes to under square root 225, okay. Yes, modulus of n bar, which is equal to square root of a 225, and we know that the square root of a 225 can be written as which is the perfect square for 15, okay. So perfect square for 15, which is a 225. So we can write modulus of n bar directly as a 15, okay. Now see that I got the value for modulus of b bar into modulus of n bar. That means I found the denominator here, modulus b bar into modulus of n bar, okay. We can substitute directly value over here. First of all, find out the b bar dot n bar, okay. So how can we define b bar dot n bar? Now see here, I'm going to find out the b bar dot n bar here, okay. So b bar dot n bar, okay. The dot product for these two vectors, okay. Dot product of these two vector means what we do, we take dot product of this one with this one with this one with this. That means 2i can be taken dot product with my 10j. 2i can be taken with the dot product of a 2j, and similarly 2i can go for the dot product with the minus 11 times k. Okay. Yes, but in our vector we know that when we get the opposite vectors like I into j cap, I cap into j cap, it always goes to 0, but I cap into I cap always goes to 1. Similarly, j cap into j cap always goes to 1, k cap into k cap always goes to 1, but k cap into some another vector like I j k, it always goes to 0. Okay, so easy part here. So what we have to do, we have to multiply 2i into 10i, okay, plus 3j into 2j plus 6k into minus of 11k. Okay, so we have to multiply their coefficient. Okay, so we can write 2 multiplied by 10. Okay, 2 multiplied by 10, this one is the first coefficient of I cap. Similarly, 3 multiplied by 2, this one is the coefficient of a j, and third coefficient plus 6 multiplied by minus 11. Okay, these are the all coefficient for I cap, j cap and k cap here. Okay, yes, and we have to find out the value for there. Okay, so 10 to the 100, sorry, 10 to the 20, 3 to the 6 and 11 6 the negative of 66, it is coming here. Okay, so totally b bar dot n bar. Okay, find out the calculation, we will get the b bar dot n bar as 21. Okay, so find out the b bar dot n bar, you can easily define the value over here. Okay, so we can write it as the b bar dot n bar, modulus of b bar dot modulus of n bar. So what is the multiplication for modulus of b bar dot modulus of n bar? We have to find out their multiplication over here. Okay, so which is goes to the 15 multiplied by 9. Okay, so 15 mod b bar into mod b bar into n bar. So we have denominator mod b bar into mod n bar as a here denominator, and b bar dot n bar as the part of a numerator. Okay, so mod b bar into mod n bar. Okay, so go for the 15 multiplied by now it's not a 9, it is a 7. Okay, so by mistakenly I written here square root of 49, it goes to the 7. Okay, not a 9. Okay, so we want the denominator as a mod b bar into mod n bar. Okay, that means 7 multiplied by 15. Okay, okay, so mod b bar, let's find out the value for mod b bar into mod n bar. Okay, so mod b bar here 7 multiplied by 50. Why am I multiplying this? Because we have denominator here, I'm trying to find out the directly value for denominator. Okay, 7 15s. Okay, 105, 15 7s are 105. Okay, okay, yes, it is say 15 7s are 105. So I got the modulus of a b bar into modulus of n bar, which is a 105 here. Okay, so the left part here to find out the value for b bar dot n bar. So 2 10s are 20 plus 3 2s are 6 minus 11 6 are minus 66. Okay, okay, so 20 minus 60. Okay, so we get the minus 40. Yes, it is a minus 40 here. Okay, this one is the value b bar dot n bar, which is a minus of 40 here, and modulus of b bar dot modulus of n bar, which is a negative 105 here. Okay, let's go for finding the next values. Okay, so here I'm going to find it here. So sine theta can be written as b bar dot n bar. Okay, b bar dot n bar, which is a negative of 40, completely divided by modulus of b bar into modulus of n bar, which is a 105. Okay, negative of 40 divided by 105, and completely entire bracket which is having modulus here. Okay, so that means our sine theta always gives us the positive value, that's why modulus it is there. Okay, yes, go for the division of 5, so we will get the simplified term. Okay, so we have to divide it by 5, so we get the 8 by 21. Okay, so we can write this one is the 8 by 21. So if you want, just divide with the 5, we will get the required answer. Okay, so divide by 5, 8 5s are 40. Okay, so negative under modulus, it goes to the positive, there is no effect for negative sign. 105 divided by 5, we can write 21 5s are 105. Okay, yes, so we got the sine theta which is the 8 by 21. Okay, so we got the sine theta which is equal to 8 divided by 21. Okay, this one is the value for sine theta which is equal to 8 divided by 21. But in our example, what we want, we want the acute angle between the line and plane. Okay, so we want the acute angle between line and plane. Okay, that means we want the value for theta only. Okay, so value for theta, so can take sine to the other side. We know that sine, if goes to the domain to codomain or codomain to domain, it gives us the inverse function. Okay, so we can write sine theta as a sine inverse of 8 divided by 21. Okay, this one is our required answer from our example. Now see that how easy type of the question we have here. Just need to apply the sum of basic concept that you need to know here for finding the position vector. Okay, for using our line and plane. Second, how to take their dot product. Okay, and how to find their modulus. Okay, these two concepts are important here. Okay, directly apply this standard formula. Sin theta is equal to b bar into n bar upon modulus of b bar into modulus of n bar. Okay, so when we have acute angle between line and plane. Okay, so I'm expecting that you all have understood this entire solution. Let's move for the next example, and correct option is here sine inverse of 8 by 21. Okay, so option first, sine inverse of 8 by 21, which is a correct option. Okay, let's move for the next example. Now see that when we want the acute angle between line and the plane, then we use the sine theta. Okay, okay, between line and plane. And when we want the acute angle between two plane itself, then we want the cos theta. Okay, always remember these two difference. Okay, acute angle between two plane. Okay, we have to find here, find acute angle between two plane. We want the acute angle between two plane over here. Okay, and the two planes are given. First plane we have here x plus y plus 2z, x plus y plus 2z, which is equal to 3, which is the first plane. Second plane we have here 3x minus 2 times y plus 2 times z, which is equal to 7. Okay, these are the two plane we have given in our example, and we have to find out the acute angle between two planes. Okay, we want the acute angle between two planes. For finding the acute angle between two plane, we know that we can write it as the first plane as a n1 cap, second plane one as a n2 cap. Okay, so when we have line and plane, we consider line as a b bar. Okay, and plane as a n bar. Okay, so but here we have two plane, so consider first plane as a n1 bar and second plane as a vector n2 bar. Okay, so first plane can be written as n1 bar. Okay, and n1 bar can be written as I plus j plus 2k, which is equal to 0. Okay, so n1 bar can be written as coefficient of this xyz only. Okay, I plus j, that means we have the coefficient of x, which is a 1. That means we take the coefficient of I, which is 1. Similarly, the coefficient of y, which is 1. So that's why we are taking coefficient of a j, which is 1, and coefficient of a z, which is here 2. So consider the coefficient of a k, which is 2. Okay, so I plus j plus 2 times k. Okay, I plus j plus 2 times k, which is the first plane. Okay, go for the second plane. Define the second plane here. Second plane I can define here as a n2 bar. Okay, and n2 bar can be written as 3 times I cap minus 2 times j cap plus 2 times k cap. Okay, this one is our second plane here. Okay, 3i minus 2j plus 2k, which is our second plane. Okay, now for finding the value of a angle between two planes. Okay, angle between two planes, we write angle between two planes. Okay, angle between two planes, angle between two planes, we write this one as, okay, angle between two planes, we write it as a cos theta can be written as under modulus n1 bar into n2 bar. Okay, divided by modulus of n1 bar into modulus of n2 bar. Okay, so n1 bar into n2 bar upon modulus of n1 bar into modulus of n2 bar. Okay, this one is our required result for cos theta that we are going to apply between angle between two same plane here. Okay, okay, so we want the angle between two plane, that means we want the n1 bar into n2 bar. Okay, so find out the value for n1 bar multiplied by n2 bar, that means vector n1 bar multiplied by vector n2 bar. Okay, always remember that for finding the multiplication between two vectors, we know that I cap dot I cap always goes to 1, j cap dot j cap always goes to 1, k cap dot k cap also it goes to 1. Okay, but when we take I cap into j cap into k cap into I cap, so these are the odd vector always goes to 0. Okay, yes, so what we do here, take n1 dot n1 vector n1 bar dot n2 bar. Okay, that means the coefficient of I cap multiplied by coefficient of I cap, so 1 multiplied by 3 plus, okay, second 1 multiplied by minus 2 plus 2 multiplied by 2. Okay, 2 multiplied by 2 here. So n1 bar dot n2 bar can be written as 1 multiplied by 3, which is a 3, 1 multiplied by minus 2, which is a minus 2, and plus 2 multiplied by 2, which is a 4 here. Okay, yes, so 3 minus 2 can be written as 1. Okay, 3 minus 2 can be written as 1 plus 4 here. Okay, so 1 plus 4 can be written as 5. Okay, so vector n1 bar into n2 bar, we write it as the 5 here. Okay, so I got the value for vector n1 bar into n2 bar, which is equal to 5 here. Okay, vector n1 bar into vector n2 bar, which is equal to 5. Now next, what we want here, modulus of n1 bar into modulus of n2 bar. Okay, now let's go for finding the modulus of a two number, as I explained earlier, for finding the modulus of a number. Okay, so modulus of n1 bar, okay, modulus of n1 bar can be written as under square root coefficient of first term square. Okay, that means 1 square, coefficient of a second term square, that means again 1 square, and coefficient of a third term square, that means here 2 square. Okay, here all these three are the coefficient of our I, j, k square here. Okay, now let's go for finding their values. So 1 square plus 1 square plus 1 square, 1 plus 1, which is a 2 plus 2 square. Okay, 2 square, which is a 4, 4 plus 2, 6. We got the square root of a 6 here as a modulus of n1 bar, which is equal to square root of a 6. We have the value. Okay, this one is the modulus of n1 bar, which is the square root of 6 here. Okay, similarly find out the square root of modulus of n2 bar. Okay, for finding the modulus of n2 bar, we have to consider the coefficient from next position vector n2 bar. Okay, so modulus of n2 bar, okay, let's go for the modulus of n2 bar, can be written as square root of 3 square of a 3 square plus square root of a minus 2 square plus square root of a 2 square. Okay, this is the square root term square. Okay, 3 square, which is a 9, minus 2 square, which is a 4, 2 square, which is a 4. Okay, this one is a 4, 8 and 9, 8 and 9, we can take it as the 15. Okay, okay, so we got the modulus of n2 bar, which is a square root of 15. So this one is a, okay, 9 and 13, okay, 9, 10. What we have the value? 9 here and 4, which is a 13 and 4, which is a 17, not a 15. Okay, okay, let me write it into the next step. Okay, 4 and 4, 8, 8 and 8, 16, 17. So we take it as the modulus of n2 bar as a, and modulus of n2 bar, we can write it as the 17. Okay, okay, that is 8, 4, 4, 8, 8 and 9, which is a 17. Okay, yes, so modulus of n1 bar, modulus of n, we have modulus of n2 bar, modulus of n1 bar. Let me show this one here. So here we can see it as modulus of n2 bar, we have modulus of n1 bar. Okay, and n1 into n1 vector and n2 vector we have here. Okay, substitute all these values in our cos theta. Let's see what the value for cos theta gives us here. Okay, So cos theta can be written as under modulus of n1 bar into n2 bar. Okay, n1 bar into n2 bar, what we have here, 5. Okay, completely divided by modulus of n1 bar, modulus of n2 bar. Okay, modulus of n1 bar, which is a root 6. Okay, and modulus of n2 bar, which is a root 17. Okay, so this one is entire value for cos theta, which is equal to, okay, root 6 into root 17. Okay, so keep that value as it is. Let's go for taking the merging that two different square root. Okay, merge these two square root, we will get the 17 multiplied by 6. Okay, so I can write cos theta as modulus of 5 divided by square root of a into square root of b. We can write square root of a into b here. Okay, so square root of 6 multiplied by 17. Okay, this one is the value. Okay, so 6 multiplied by 17. So 17 6 we know that 17 6 which is a 102 here. Okay, so we can write 5 divided by square root of 102. Okay, this one is the value. Okay, now what we do, write down the value for theta only, as we have cos theta we have here. Okay, so we want the only value for theta. So theta can be written as, take to the image from the domain to codomain. So we will get the theta, which is equal to cos inverse of 5 divided by square root of 102. Okay, this one is the value for theta. Okay, a required value for theta, which is your cos inverse of 5 by 102. Okay, so we can see that in our option number second, we have given cos inverse of 5 divided by square root of 102, which is our required answer. Okay, I hope you all have understood this solution. Very easy solution we have here. Just need to understand the difference between line and a plane. Okay, so when we have two plane together, which result need to apply? When we have line and plane, then that time also the result. Okay, this condition are important here. Now let's move for the next example. Okay, so in our next example, point A given. Okay, so point A given, lambda 5 minus 2 lies on the line. Okay, line also given, equation of a line, then the value of a lambda we have to find it out here. Okay, so very easy solution, this one is here. Okay, we just have to define the value where lambda satisfy our whole given equation of a line. Okay, now let me write what we have given first. Okay, point given we have here, we have given the point. Okay, so point we have given A lambda 5 minus 2. Okay, so we have given point A, which is a lambda 5 minus 2. Okay, lies on the line. Okay, lies on the line. Okay, that means if any point which lies on our line, that what that point do here. Okay, what that point does, actually the point which lies on any line, that point satisfy the given equation of a line. Okay, that means in actual, the point on a line which is the root or the solution of that line. Okay, so which exists there. Okay, so lies on the line which is x plus 1 divided by 7, which is equal to y plus 1 divided by minus 6, and z plus 1 divided by 1. Okay, this one is the, and then find out the value for lambda. Okay, so we want the value for, find what we want here, find the value for lambda here. Okay, we want the value for a lambda here. Okay, using our given data. Now we can see it here, our point given which lies on our line A here. Okay, so we can see we can easily put the value for x, y and z that can satisfy the equation of our lambda here. Okay, okay, now see that minus 7 and x which is equal to 7 minus 8. So we can see that here the point which satisfy the equation of a line. Okay, equation of a line which we directly can write the point which satisfy the equation of a line, which is equal to minus 8 when we substitute the value for 5. Now see that if I substitute the value for lambda which is a 5. Okay, so 5 plus 1. Okay, 5 plus 1 and 6 divided by minus 6, which gets the minus 1. So 5 satisfy our equation here. Okay, so similarly minus 2 also. So minus 2 plus 1, which gives us the minus 1 divided by 1. So which satisfy the value which gives us the minus 1. Similarly, now see that if it is a minus 1 here, minus 1 here, that means we want the solution from this side which also minus 1. Okay, That means what value it is possible here that we can get the -1. So we can see that if I substitute x as a -8, okay. Now see that, let me explain it one more time. Okay, so in our equation, we can see that if a point lies on this line, that means the point A, which is the solution for our given line, okay. So this point A, which is the solution for this line, okay. That means the point vertices x, y, z, which is here in our point A, which satisfy this equation of a line, okay. So now see that the value for x, which is lambda, y, which is equal to 5, and z, which is equal to -2. If I'm going to substitute this value here, now check it out. This is the basic calculation that we are using counter type of the solution, whether to identify given a point is having our solution or not, okay. Now see that x plus 1 divided by 7 we have here, y plus 1 divided by -6 here, and z plus 1 divided by 1, okay. This is the part of a logic that we can easily define the value. Now we can see that when I substitute -2 as a z, okay, now see that this one is the value for x, y, and z, okay. So this point lies on this line, and if any point lies on the line, that means this one is the root or a solution for our line, okay. So lambda 5 -2 are the solution of this line, okay. So put the -2 here, -2 plus 1 upon 1. Put the 5 here instead of a y, so 5 plus 1 upon -6, okay. And put the value for put the value for lambda here, okay. Lambda plus 1 upon 7, okay. So we don't know the value for lambda, but we know that the comparison of these three sides are equal, okay. That means the answer coming from this side, answer coming from this side, and answer coming from this side all need to be equal here, okay. So we go for the next calculations. So 5 plus 1, which gives us 6, 6 divided by -6, which gives us the 1. So -2 plus 1, which gives us -1, and -1 divided by -1 divided by 1, which gives us the value 1. Similarly, do it for lambda plus 1 divided by 6. So we want the value for lambda such a way that the lambda plus 1 divided by 7 gives us the -1, okay. So what is the value for lambda? If I'm going to substitute the value lambda as a -8, okay. So if I'm going to substitute lambda as a -8, -8 plus 1 divided by 7, we will get it here, okay. So -8 plus 1, that is -7, and -7 divided by 7, which gives us -1, -1, and -1. Now see that all three sides are coming equal. That means the value for lambda need to be a -8 only then we get the three sides are equivalent, okay. So easily by using just a part of logic, we can define the answer over here, okay. So we got the value for lambda, which is a -8, and we can see here the option D, which says that lambda which is equal to -8, which is the answer, okay. And if you wanted to counter option, okay, so just go for directly substitution of the option in our given equation of a line here, okay. Substitute here and find out whether which point gives us the all sides are equal, okay. That will be the solution for you all, okay. So I'm expecting that you all have understood this solution. We don't have anything here, just don't need to apply any condition concept, just need to go through only the condition for a line and the point which lies on a line, okay. So here you have to remember only one thing: if any point which lies on our line, that means the point which is there on line, which is the solution or root of that line, which satisfy always that line, okay. So that is the condition we have to apply here. I'm expecting you all have understood. Now let's move for the next question. The Cartesian equation of the line passing through the point, we have given point A 4, 2, 1. We have given point A 4 to 1 and point B given, okay, 2, -1 and 3. Point B given 2, -1, 3, okay. So we have point A, point B we have here, okay, passing through the point, okay, which passing through the point, okay, the Cartesian equation of the line which passing through the point. So what we want here, basically we have to find out the value for Cartesian equation of a line, okay. Cartesian equation of a line, okay. So what we want here, we want the Cartesian equation of our line, okay. So for finding the Cartesian equation of a line, we know that we use the standard result for Cartesian equation of a line, which is x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1 and z minus z1 upon z2 minus z1. Okay, so we can write this one as x minus x1 upon x2 minus x1, okay, which is equal to, similarly for the coefficient Cartesian equation for y also, that means the coefficient of y also, y minus y1 upon y2 minus y1, okay, and z minus z1 upon z2 minus z1. Okay, so we want all these values here. Okay, x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1, and z minus z1 upon z2 minus z1, which is the Cartesian equation of a line. Okay, so now we have to find out the value for x1 y1 z1, x2 y2 z2. Okay, okay, so here we can consider that this one is x1, this one is y1, this one is z1, x2 y2 z2. Okay, substitute these values here then. Okay, x1 y1 z1. Okay, so we can consider x1 y1 z1, x2 y2 z2. Okay, so we can see that x minus x1, x minus 4 upon x2 minus x1, so x2, that means 2 minus 4, it is coming there. Okay, so we can write it as the 2 minus 4 here. So now substitute all these values in our result. Okay, so let me write this value separately so you can understand it well. Okay, x1, here we have here 4. Okay, value for x1 4. Again y1 we have here 2 again. Okay, let me write this one again. The value for x1 we have here 4, y1 we have 2, and z1 we have here 1 here. Okay, yes, x1 y1 z1. Similarly x2, here value for x2 which is a 2, y2 which is here a minus 1, and z2 which is equal to 3. Okay, x2 y2 z2, 2 minus 1 3 here. Okay, so we have the value for x1 y1 z1, x2 y2 z2. Need to substitute all these values here, you will get the required Cartesian equation of our line here. Okay, so Cartesian equation of a line, it says that x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1. Okay, so we don't have the value for x, so as we want the in our Cartesian form, the value for x, y, z as it is, so keep them as it is, don't go for any adjustment. So x minus value for x1 which is a 4, x minus 4 divided by x2 minus x1, that means 2 minus 4. Okay, 2 minus 4, be careful about their sign, positive negative sign. Okay, 2 minus 4, 2 minus 4. Okay, x minus x1 upon x2 minus x1. Similarly y minus y1. Okay, so y minus y1 which is here 2, y minus 2 upon y2 minus y1, so y2 minus y1, minus 1 minus 2. Okay, so minus 1 minus 2, so y2 minus y1 means minus 1 minus 2 here. Similarly z minus z1. Okay, z minus z1, value for z1 we have here 1, z minus 1. Okay, z minus 1 upon z2 minus z1, so z2 minus z1, so 3 minus 1, 3 minus 1 which is coming here. Okay, so x minus 4 keep as it is, 2 minus 4 which gives us minus 2, y minus 2 as it is, minus 1 minus 2 which gives minus 3, z minus 1 keep as it is, 3 minus 1 we write it as the 2 here. Okay, now see that in our option number, which option it is correct. So this one is our required answer for our Cartesian equation of a line. Okay, so which is the Cartesian equation of a line that we want in our example here. Okay, now verify which one of the option is correct. So x minus 4 divided by minus 2, which gives us option B and D. After that y minus 2 divided by minus 3, so which gives us option only B. So our required option B which is correct here. Okay, so this one is a B option correct. Okay, I am expecting that you all have understood this my entire solution. Okay, even after if you found anything difficult, anything confusing, let me know in my comment section. I will come up with the similar videos. Okay, now let's move for the next solution. I'm expecting you will have understood everything here. Okay, and if you want the entire solution for this my lecture, you do check in my description box. You will get the entire PDF of my complete lecture. Okay, so you will get that PDF there. Okay, now let's move for the next example. We have given our line given here. Okay, line which is equal to r bar into I minus 2j plus 3k plus lambda into another variable. That means a plus lambda b. This one is the equation of a line which is given. is a parallel to the plane, and equation of a plane which is given r bar into n bar, which is equal to, okay, 10 given. Okay, and the value of a m then we want here. Okay, we have to find out the value for m here. Okay, now let me write first of all what we have given in our solution. Okay, example what we have given, let me write first. Okay, so we have given line, equation of line, equation of a line. Okay, equation of a line, we have equation of a line. What is the equation of a line? Which is a r bar, which is equal to I minus 2j plus 3k, I minus 2j plus 3k. Okay, so I cap minus 2j cap plus 3 cap, which is the first equation of a line. Okay, plus lambda into another part is a 2i plus j plus 2k, 2i plus j plus 2k. Okay, this one is our equation of a line, we have given r bar. Okay, and the equation which is a parallel to the plane. Okay, and the equation of a plane we have given equation of a plane, we have given equation of a plane. Okay, so equation of a plane which is a r bar dot 3 times I cap minus 2 times j cap. Okay, plus m times k cap. Okay, which is equal to 10, which is equal to 10. Okay, then we want the value for m. Okay, so what we want, claim we have here, we have claim here the value for m here. Okay, so we want the value for m here. Okay, so what we do, first of all, compare the standard equation of a line, which is r bar, which is equal to a bar plus lambda times b bar, and both of the equation of a line and equation of a plane, they are both are the parallel to each other. Okay, okay, both are the, these two are the parallel. Okay, parallel to each other. Okay, so both equation of a line and plane, both are the parallel to each other. Okay, so we have to apply the condition here. When equation of a line which is a parallel to each other, equation of a line and plane which are the parallel to each other, then we will apply the condition. Okay, so first of all, compare the equation of a line which is equal, this equation of a line which is equal to standard form, r bar which is equal to a bar plus lambda times b bar here. Okay, r bar which is equal to a bar plus lambda times b bar. So it gives us the value for a bar which is equal to I minus 2j plus 3k, and b bar which is equal to 2i plus j plus 2k. Okay, so this is the value for a bar and b bar we have here. Okay, now find out the, write down the separately value for a bar, b bar. Okay, so a bar, by using equation of a line, we write a bar as a I minus 2j plus 3k, because I'm comparing this with the a bar plus lambda times b bar. Okay, so this one is a bar plus lambda times b bar. So a bar here plus lambda times b bar here. Okay, so a bar can be written as I cap minus 2 times j cap. Okay, plus 3 times k cap. Okay, so this one is our I cap plus 2 times minus 2 times j cap plus 3 times k cap. Similarly, b bar, lambda times b bar here. So b bar can be written as 2 times I cap plus j cap plus 2 times k cap. Okay, this one is the a bar, value for a bar and b bar I found using the equation of a line, which is the a bar plus lambda times b bar here. Okay, okay, so after that, equation of a line parallel to plane, and we have given parallel to plane which is equal to r bar into 3i minus 2j plus mk, which is equal to 10 given. Okay, then direction ratios of the normal of a plane. Okay, so we can write the direction ratios of the normal of a plane using this one. Okay, using this one equation of a plane, we write direction ratios. Okay, drs of normal of a plane. Okay, direction ratios of a normal of a plane. So direction ratios gives us the coefficient of I cap, j cap and k cap. Okay, so the direction ratios can be written as 3 minus 2 and m. These three are the direction ratios for our given normal of a plane here. Okay, now using this one, let's go for finding the value. Okay, so we have the line parallel to the plane, so we can take the dot product of 2i plus j plus 2k. So that means 2i plus j plus 2k, the b bar into multiplication of this one 3i minus 2j plus mk, which gives us the value 0. Okay, so we can write this one as 2i plus j plus 2k, 2i plus j plus 2k multiplied by 3i minus 2j minus mk. Okay, 3i minus 2j plus mk, we can take their dot product as a 0. So how we are taking, why we are taking the dot product 0? Now we can see here, let me explain. Okay, now see that r bar into n bar, which is equal to some constant given. So this n bar has to be a dot product with a b bar. Okay, lambda times b bar. If we take their dot product here, this one, so it always gives us the value 0. Okay, so that means we write 2 times I cap plus j cap plus 2 times k cap multiplied by next n cap. Okay, so 3 times I cap minus 2 times j cap plus m times k cap, which gives us the value 0. So we can take their dot product as a 0 because this line and plane are having parallel. Okay, they are the having condition which is the parallel between of them. Okay, so this b bar, lambda times b bar and r times n cap, their dot product need to be 0. Okay, so go for the taking dot product between two vectors. Okay, so taking dot product between two vectors, we know that I cap into I cap, which always goes to 1. I cap into j cap, it goes to 0. J cap, k cap, it goes to 0. Okay, so this is the way to find out the dot product of two vector. Okay, 2 I cap into 3 I cap. So I cap into I cap, it goes to 1. So 2 3s are each remains 6. Okay, plus minus, it goes to minus, plus j cap into minus 2 j cap. So it gives us the only 1 into minus 2, which is negative of 2. Okay, plus 2 k cap into m k cap, we can write here as a 2 m into k cap, it gives us the value 1, which is equal to 0. Okay, so 6 minus 2, we can write it as the 4 plus 2m, which is equal to 0. So m, which is equal to minus 4 divided by 2, and we can write m, which is equal to minus 2 over here. Okay, this one is our required answer. So our option A, which gives us the m, which is equal to minus 2, which is our required solution for our equation of a line. Okay, so we by using equation of a line and a plane, I found here the value for m as a minus 2 here. Okay, I hope you all have understood this solution. Okay, still 2 examples remaining. Okay, okay, now let's go for the next example. In our example number 6, we have given equation of a line passing through the point. Okay, we have to find out the equation of a line. Equation of line. What we want here? Equation of a line here. Okay, so we want the equation of a line which passing through the point. So we have point 0 0 0 and 2 1 minus 3. Okay, so we want the equation of a line which passing between these 2 points. Okay, so passing between these 2 points. Okay, so we know that equation of a line which passing from x1 y1 z1, we can write this one as, let me write the standard result over here. Okay, equation of a line passing through, equation of a line which is a passing through x1 y1 z1 and x2 y2 z2, equation of a line passing through x1 y1 z1 and x2 y2 z2 is. Okay, so we want the equation of a line passing through the point x1 y1 z1, x2 y2 z2 is x minus x1 upon x2 minus x1. Okay, so we write x minus x1 upon x2 minus x1. Similarly, y minus y1 upon y2 minus y1. Okay, y minus y1 upon y2 minus y1. Okay, which is equal to z minus z1 upon z2 minus z1. Okay, so this one is the equation of a line which passing through 2 different points. Okay, now we have x1 y1 z1 here, x2 y2 z2. Now what is the value for x1? 0, y1 0, z1 0. Okay, this one is x1, this one is y1, this one is z1. Okay, similarly go for x2 y2 z2. So value for x2 which is a 2, y2 which is equal to 1, and z2 which is equal to minus 3. Okay, so substitute x1 y1 z1, x2 y2 z2 in our equation of a line. Okay, passing through these 2 points. Okay, so x minus x1, so x minus x1 means x minus 0, okay, upon x2 minus x1, x2 minus x1, that means a 2 minus 0, which is equal to y minus y1, so y minus 0 upon y2 minus y1, okay, 1 minus 0, okay, 1 minus 0, okay, y minus y1 upon y2 minus y1. Similarly, z minus z1, okay, z minus z1, which is a 0, upon z2 minus z1, okay, z2 minus z1, minus 3 minus 0, okay, minus 3 minus 0. Go for next calculation, we get the x divided by 2, which is equal to y divided by 1, which is equal to z divided by minus 3, okay, which is our required answer. Now see that which one of the option is correct, verify with this answer, okay. So this one is our required answer. Now see that answer, it is coming only in one step. Just we need to understand here the standard formula. When we have the 2 points and we want the equation of a line which passing through these 2 points, so we write that one is a x by 2, y by 1 and z divided by minus 3, okay. Now verified which one of the option is correct, okay, x by 2, y by 1, z by divided by minus 3, which gives us our option number first, which is correct here, okay. I hope you all have understood this solution. Answer, it is coming only in a 2 to 3 step only, okay. So we don't have anything here. Let's move for the next solution. Okay, this one is the last solution for our last example for our today's lecture, okay. We want the equation of a plane passing through 2 minus 1 3 and making equal intercept on the coordinate axis, okay. What we want? Equation of a plane, okay. Okay, we want the equation of a plane, okay. We want the equation of a plane here, okay. What we have to find here, basically we have to find out the equation of a plane, okay, passing through the point, okay. So we have given point, given data. Let me write what we have given, that equation of a plane passing through the point, okay. So we have given point here 2 minus 1 3, which passing through this point, making equal intercept on the coordinate axis, okay. Making equal intercept on the coordinate axis. Making equal intercept on coordinate axis. Okay, making equal intercept on the coordinate axis. Now we want the equation of a line, okay, passing through the, we want the equation of a line, okay, which is passing through this point, okay. So point we have given here, okay. So we know that equation of a plane, okay, we know that equation of a plane making equal intercept on the coordinate can be written as x plus y plus z, which is equal to k, okay. So we can write equation of a plane making a equal intercept on the coordinate axis. We can write x plus y plus z, which is equal to k here, okay. When we write this one, when we have the equation of a line which is making equal intercept, okay, which making equal intercept between coordinate axis, okay. That means when we add the coordinate for x, coordinate for y and coordinate for z, we get the constant value, okay, like x plus y plus z, which is equal to k here, okay. Now the value for x plus y plus z is a k, that means 2 plus minus 1, okay, 2 plus minus 1 plus 3, which is equal to k, okay. That means 2 plus minus 1 plus 3, which is equal to k here, okay. This one is the equation of a line for passing through the equal intercept of the coordinate, okay, coordinate axis. Now let's go for the next addition. 2 minus 1, we can write it as the 1 plus 3, okay, which is the value for k. So k, I got the value for k, which is a 4 here, okay. I get the value for k, which is a 4. Now revert back that k in our given solution, given equation of a line here, okay. So we can write x plus y plus z, the value for k I found here, which is a 4, okay. This one is the equation of a line passing through 2 minus 1 3 and making equal intercept with the coordinate axis. So this one is our required answer. Now see that in our option number 4, in our option number 4, we have given x plus y plus z, which is equal to 4, okay. So in our example, we just need to know one thing here. Whenever equation of a line passing through some certain point, okay, and which makes equal intercept on our x-axis, y-axis and z-axis, then we can write the coefficient for x-axis, y-axis and z-axis, addition for this x, y, z always gives us the constant value. Okay, that means x plus y plus z, which is equal to k. Okay, now what I have done, I substitute the value coordinate for x, y, z here, then it gives me the value for k, and revert back the value for k. I got the required answer. Okay, so that's it here for our today's lecture. Okay, so I'm expecting that you all have understood this example. Now let me go for little recap. What we have learned so far. Okay, so at the beginning I explained some of the basic concept from the vector chapter. Okay, then direction ratios, direction cosines. After that, we have taken Cartesian form of the equation of a line. Okay, equation of plane we learn here, equation of a line we learn here. We have taken some of the example based on this. Okay, so I'm expecting that you all have understood my today's lecture. Nothing it is difficult here. Even after, if you found anything difficult, let me know in my comment section. I will come up with the similar videos. So you will get the solution, entire solution for this lecture in my description box. Okay, so thank you everyone. Thank you for my today's lecture.